you think? Is it on there already? Give me the second mic. When it ends. Yeah, it's numbers actually. So let's position
So,
Will you make sure you introduce all your team members as you get started?
okay, it's part of the once is the
Mic test,
the
mic
green light.
test.
Okay, sure.
Would you like us to just introduce the names or?
Hello.
Your name and your
Mic test, mic test. Just let Mel do it. Mel.
Okay. So I'm Melanie. Can you hear from me? This is Gandit, Nigel, and Zen. So, did you know that 26 million people in Tanzania drink contaminated water on a daily basis? We are the team Screen Magic and would like to do something about this. That's why we're here today. I should start again.
I would start again.
Okay.
I'm sorry, I know you had to figure out. Let's introduce your team,
Okay.
all your teammates.
Okay. All right.
Wait, the timer is still running? Yeah,
We'll reset the timer. Good thing you checked.
Okay. Good morning. I'm Melanie. This is Gandit, Nigel, Sen, and Gandit. So, did you know that 26 million people in Tanzania drink contaminated water on a daily basis? We are the team Screen Magic and would like to do something about this. That's why we're here today to present you with our SKM 1000, a system that can transform 1,000 liters of dirty water into 1,000 liters of potable water by using the natural resources of this country. We are a team of dedicated students at Heriot-Watt University that decided to come together in order to help achieve the Sustainable Development Goal number 6, clean water and sanitation. Why did we choose Tanzania? There's room for access in improvement for clean water all around the globe, but we decided to choose Tanzania for numerous reasons. The main one being that we directly observed a need for access to clean water due to waterborne diseases being the main cause for children's death in this country. And when I say directly, I mean directly. In 2015, I traveled to Tanzania with a friend of mine to visit his family. On my 9th day of visit, I felt sick due to bacterial diarrhea, for which I had to get medical treatment. This girl in the picture is Sakina, my friend's niece. She's only 6 years old, and during my visit there, as you can see, she was fresh as a daisy. It only took 23 days before I was back in the UK that I was notified by my friend that Sakina had passed away due to suddenly falling sick of severe cholera. As Sakina, 45% of Tanzanian children are at constant risk of falling sick due to contamination of water, stopping them from attending school, enjoying their childhood, and some even dying at young ages. So our project aims to help improve lives of families in rural Tanzania, providing them with fresh water to drink, cook, wash their dishes and their hands, improving their health, their prosperity, and their joy of living. Our system consists on a 3 filtration process. The first filtration is the ceramic filtration, enhanced with rice husk and a little bit of silver to reduce the maintenance. Secondly, we have the biosolvent filtration, which will have activated carbon and rice husk ash. The activated carbon will be formed by burning waste coconut fiber and soaking it in a salty solution throughout night. This will remove the heavy metals and improve the taste of the water. Finally, we have the solar pasteurization tank, in which the water will reach 70 degrees Celsius, and with the aid of the sunlight, mirrors and phase change materials. Our system is simple, cheap, and it is designed to meet the local skills of Tanzania workforce. So now my colleague Nigel is going to tell us a bit of how we're going to bring this project into action.
Okay. As Melanie said, we have a working concept, but the thing is, it's all right, I do it back. But the thing is, what this project has highlighted to us is that it shows us how difficult it is to intervene in a developing country with the many stakeholders and their differing agendas coming into play. As such, we set out to investigate our environment further, and this is what we learned from these interviews right here. For starters, the Great Lakes in Tanzania are situated towards the border, making it difficult for the Tanzanian people to gain access to clean water. As a result, children like Sakina are forced to rely on shallow boreholes which are easily contaminated with water. The second problem that we ran into is during the process of developing a business model, simply because our target demographic is poor, and Tanzanians are very skeptical. And that Tanzanians are very skeptical of any foreign investment which has not been proven. Now, however, ever since 2010, under the leadership of President Magufuli, Tanzania is home to a rapidly developing infrastructure, transportation infrastructure, among the best in East Africa. And it also has a booming tourism industry in the highlands. Now, we, School Maji, we are for the Tanzanian people. And as such, we will be adopting a non-profit business model where every of our stakeholders will benefit fairly from the enterprise, but with every penny going back into our enterprise. Guess what? We'll be initially building 6 SKM 1000s and situating them in strategic locations throughout the country. And from there, each SKM 1000 will be able to filter out 2,000 liters of water a day. And from day one, we will be giving out 35% of this water to the communities that need it the most. And the rest, we'll be wholesaling it in urban areas. And this, in turn, will fund our enterprise and keep us going so that we can continue to get clean water out to the people who need it. To achieve this feat, we will be partnering with CDS, a well-established, ambitious, medium-sized Tanzanian delivery company that specializes in deliveries to all over Tanzania. Utilizing their infrastructure, we plan to get 4,200 liters of clean water to the people who need it the most every single day. And in return, we will give them the opportunity to demonstrate better corporate social responsibility, better brand development, and of course, we also give them a bit of free water for the operations and employees. I'm going to say this on a final note. We have a concept, we have a business. Personally, I've never met Sakina, but the fact that children like that are dying, it saddens me. So if you can help us in any way, I'd say thank you.
Can you talk a little bit about how you would scale this up from the initial 6 that you deploy?
Thank you, that's a lovely question. So I'm going to pass it on to Gundit. So could you repeat the question, please?
How do you scale up from your
So initially we were building in 6 critical locations, but later on we will have molds that this will be manufactured much cheaper. So it will we'll now observe what areas in Tanzania are best to develop in, and we'll aim those ones. And additionally, it could expand in East Africa where there's similar resources. Any other questions, please?
So explain to us what differentiates you from your competitors. What about this technology? We understand it's very simple and that's part of the business case, but describe a little bit how you set yourselves apart.
So I'm going to answer this one. The main thing I feel that we have over competitors is the fact that with a lot of ones that have been designed and made previously and implemented in poor countries, when the funding is gone and they try to actually replicate or basically repair it, they aren't able to. With our device, it's easy to repair and easy to maintenance in the country.
Using local materials, I heard rice husk and coconut. Can you talk a little bit more about that? And then my question is all around scaling beyond Tanzania. Do you think the solution can move into other countries across the world using their local material?
So I'm going to pass this one over to Mel.
Yes, thank you very much. So yeah, rice is a big. There's big plantations of rice in Tanzania. So we observed that there's waste rice husk that we can actually utilize. Similarly, with coconut fiber, there's a lot of coconut trees in Dar es Salaam, for instance, for which the coconuts that are being used, the fiber is just wasted. So we're going to use this in order to create an activated carbon filter. And as I mentioned for the earlier question, this could also expand over East Africa, because we could, for example, manufacture it in Tanzania with the companies that we have identified to manufacture it, and we could transport it easily to Kenya, as the borders are very easy to pass, and there are similar resources in the neighboring countries. Thank you.
Can you tell us a bit more about the funding in your business model? Where did the funding come from in the beginning? The entrepreneurs that you had on the chart? And where will the funding come from to sustain it and build the first 6 and then grow beyond 6 and then go beyond Tanzania?
So I'm going to pass that over to Nigel here, who's our finance expert.
It's a cost that we're looking to overcome. We plan on winning this GGCS to get the 50K that we need to get this started. It's not that we definitely will get this started. By hook or by crook, we will find investors that will give us the 50K. And 8,000, and it's approximated that 8,000 will be used for each SKM, 2,000 to manufacture the device itself, 2,300 to make a borehole, install the pumps and everything, and the rest will go into maintenance and marketing.
What about beyond that?
Beyond that, okay. Our estimated profits per month, we are looking at a range of $4,680 profit a month, with an expenditure of approximately $3,920 a month. So while we may not be making as much as we hope, we're doing this in the name of charity. Any other questions?
Yes.
See this box? So this will be green while you're getting started, and then it will be yellow when you have 1 minute to go. You should all see this. It will turn yellow when you have 1 minute to go, and then red when you're out of time. It will go through 2 cycles, the 7 minutes presentation and then the 6 minutes of question and answer. Are you the first speaker?
Yes.
Can you take a moment and introduce each of your team members also?
Okay.
Just their name and what they study, or their role on the team.
Including the presentation.
Yes. Yes. You'll be fine.
Okay.
Are you all ready to go? The slide advancer should be working.
Okay.
Yes?
Yes.
Great. Okay.
Thank you.
You're welcome. Judges? Okay.
Ladies and gentlemen, I feel an honor to be here and make a presentation of our device. We are the carbon detector team from Zhejiang University. Our device is a new type of after-treatment detection device for diesel exhaust gas. And through accurate detection, we can save 33% of the diesel saving and 35% of the emissions reduction. Oil shortage has brought on energy crisis, among which statistics reveal that the remaining recoverable oil reserves are only sufficient for 55 years. Meanwhile, haze, an invisible health killer, has become one of the most serious environmental problems worldwide. According to the statistics, the growth of every 10 micrograms of the PM 2.5 concentration will lead to 4% increase of the total death rate. Seeking for its inner causes, the particulate emissions of motor vehicles contribute a lot. Foremost among these are diesel vehicles, which account for 60% and 85% respectively at home and abroad. At this stage, the key to manage energy and haze problem is to govern the emissions of the diesel vehicles, and the bottleneck is to control the regeneration time of particulate filter. Nowadays, the estimate method of the regeneration times are indirect. Taking the exhaust bag pressure method, the most common technique, as an example, it reflects the clogging situation of the filter before and after DPF, which can only reflect the sum of soot and ash so as to estimate the regeneration time. But there are problems of inaccuracy. Through intensive study, our team proposed to use the radio frequency resonance to reflect the deviation of electromagnetic parameters, which can reflect the soot to regenerate DPF and ash to replace DPF respectively. The relationships between them are as follows. To implement the conception mentioned above, we complete 3 major designs of our device. For the oblique part, we use CST to simulate. We choose 65 millimeters to obtain the best result of the radio frequency deviation and sensitivity. For the detecting probe, we have invented the double compelling probe, which is more accurate and stable than the traditional single hole probe. And by using the radio frequency cutoff ring, the rate of the leakage is close to 0. Through the designs above, the accuracy of our device is improved by an order of magnitude, and the volatility is reduced by 2 orders of magnitude. In terms of social efficiency, our device achieves energy saving and emissions reduction. If promoted nationally, we can save 33% of the fuel consumption in the regeneration stage, which could have supported the diesel vehicles in Hangzhou make 1 cycle around the Earth. And the amount of the reduction is equivalent to 1.7 years of the gasoline vehicles emissions in China. Our device has applied for 9 patents and several top prizes. In addition, the trio of our device verifies practicability, while the novelty retrieval report verifies originality. Furthermore, our device has achieved the intention of cooperation with one of the top 10 brands of motor vehicles in China. We are also recommended by a member of Chinese Academy of Engineering. According to the 45 in-depth research into the diesel engines, the prevailing problems of other competitive products are as follows. And through our design, we have achieved the requirements by promoting the accuracy of measurement, extending the life cycle DPF, and reducing the impressionable features. Considering the market analysis, 4 major advantages of our device are as follows. For environmental advantages, our device is expected to achieve large-scale energy saving and emissions reduction. For the economic advantages, the cost of our device is reduced by 30% compared to the traditional device. Numerous market and policy advantages will contribute to a solid foundation in the marketization and industrialization. In the market value, in addition to the diesel vehicles, our device the potential market value is estimated to exceed 100 billion yuan. And the current measurement methods is characterized as follows. Compared to the most mainstream method, the cost of our device is reduced by 30%, and the life cycle cost is reduced by 26%. The accuracy of our device is improved by 10 times. Referring to the 5 forces model, we analyze the market from 7 aspects. From this, we can find that our device has a broad market demand. So why do customers choose us? As for the business canvas, our device is highly accurate for carbon load detection, which achieves environmental benefits of energy saving and emissions reduction. And our device has low cost and high economic efficiency. The main source of our profit comes from the selling and the government subsidy. And we decide to choose the diesel vehicles enterprises, post-processing retailers, and the government traffic department as our specific customers. High accuracy, energy saving, emissions reduction, and other advantages will promise our device to be applied on a large scale. And in the further planning, our device will focus on the expansion of commercial channels and cost reduction, as well as the optimization of extreme measurement, rapid conversion, and convenient measurement. Our team consists of 6 undergraduate students from the specialties of energy, electricity, finance, and industrial design. We sincerely hope to contribute our own effort to solve the global haze problem. Accuracy changed the human life. Accuracy saves the world. We are the carbon detector team from Zhejiang University. Thank you for your listening.
What is your key innovation in achieving this technology?
Thanks for your question. We have 2 points of innovation. The first one is that the principle, at present, quantities of researchers focusing on optimizing the current methods, such as EBP method, but we are the first one to introduce the radio frequency resonance method into this field. And the second one is that we design many kinds of structures to fit this method into the working condition of diesel engines, such as the detection probes, the oblique parts, and the resonance environment. Thank you.
My question is a little bit about the logistics on how you actually implement this. Is this being installed in new build diesel engines, or is it a retrofit to existing? Can you speak a little bit about what part of the car this is going into and how easily accessible it is in order to install it?
Thanks for your question. Through our hard working, we made it that if a current car wants to put our device into that, they don't need to change other parts of the cars, but only the connection parts of the structure between the cars and between the engines and the DPF. Thank you.
So this treatment does not require urea or anything like conventional units do. Conventional diesel engines use urea in the post treatment to remove all the soot and the nitrous oxides, primarily nitrous oxide. So is this primarily just then for soot?
May I beg your pardon again?
This just filters soot, not nitrous oxide?
What specifically is filtered by your technology?
Our filter is about 100 micrometers, and the specific of our DPF is just like the device shown in front of you. And different DPF is suitable for different diesel cars.
So okay, if you look at especially the deployment of diesel engines in Europe or in North America, in addition to particles, you also have to control oxides of nitrogen, where you can't use it. So this has to be used in conjunction with some other form of exhaust treatment to remove the nitrous oxides?
Yes, there are also post treatment of this DPF, like DOC, and DPF is just under the DOC, and we are connected together, and our device is mainly to detect the DPF, the carbon load of the DPF, and we are not, and the whole system is just suitable for the nowadays system.
I'm curious as to whether this system, when installed on a vehicle, and any testing you've done, what does it have any impact on the performance of the engines?
Thanks for your question. This is part of the design that we have not taken into consideration, and the next step we will put more consideration in it. Thank you.
I just want to clarify this question. Does it have some impact to the performance of the engine after using your device?
Actually, the main influence of the DPF is just a common, for like DPF putting after the diesel engine. It will some kind of lower the efficiency of the diesel engine. But actually, the efficiency lowered is not such significant, and more significantly, our devices can reduce the DPF, can reduce the influence of the DPF, such as the DPF used before, and our device used now can lower the influence. Such as we just take this method to lower the energy consumption and the emission reduction. This is the key. This is more important for a diesel car to meet nowadays to meet the demand of our nowadays.
I think we're out of time. Thank you, team.
So I'm keep the wrong thing. Do we swap microphones?
The microphones, you can use these or the
Great, thank you. Do we have a microphone each?
you may use a microphone each.
Okay, is there a third one?
Is this it here? This? Is this a clicker? Oh, it is. Oh, I see. It's got a very, very big button for go forward. That's helpful.
How do you get back?
Okay. You can go back with the tiny button.
Great. Okay.
Don't go back.
Hello?
Right.
And,
Judges, are you ready? Yes. You can begin when you're.
Hello? It has a video as well, but we need to be clicked on.
You should be able to do it.
Just click on the screen here. Yes, yeah, but it will need a click to activate the video. Okay, great.
Just click next to it.
Okay. Well, good morning. My name is Chris. My name is Russell.
I'm Anna.
And we are Arm Prosthetics from the University of Sheffield. I'd like to begin by introducing you to Mamusu Taronka. She's a single mother living in Sierra Leone, and on a daily basis, she struggles to cater for a large family. She feels alienated from her local community, and she finds it near impossible to hold down a job. And all of this is because she's an upper limb amputee. And unfortunately, she's very far from alone in this. In fact, of the millions of upper limb amputees around the world, a huge number live in the developing world, and the vast majority of them do not have proper access to prosthetic care. This means they have to travel impossible distances to the local clinic and leave behind those who are dependent on them. And just to add insult to injury, those who can go the distance can very rarely afford the care they need. You can see here the blue column is the Red Cross estimate for manufacturing and distributing a prosthetic, which is enormous compared to the average annual income of many people living in Sierra Leone. And actually, based on our calculations, we believe it's unreasonable to ask for more than $50 for a prosthetic for someone to pay in this position. So in summary, there is a significant need for prosthetics that are both affordable, accessible, and technologically feasible in the developing world. So what is the solution? Anna.
Thank you, Chris. So our idea is to use existing technology, but creating it with recycle repurpose parts. As you can see in the video, if it was playing, the prosthetic arm would strap on the arm, and you would use the extension of the back muscles to create tension in the cable, which in turn would close the pincers. This is not a new mechanism. However, the unique point in our project is that it's made for a very low cost. We managed for the first time to push down the prices so much that for the end users will be able to afford to pay for both labor and materials. This is something that is never done. Our design is easy to make. It only took Russell 30 minutes in his kitchen to make it using a $3 multi-tool and a pair of wire cutters. Previously, Russell didn't have any expertise on bicycles. The second great thing of our product, though, is that it's maintainable. Arm amputees will no longer have to walk great distances to get their prosthetic fixed. Now, all they got to do is to find a local handyman in their community that will fix it for them. We believe that the most advanced application of technology is not necessarily the same as the application of the most advanced technology. Sometimes simple is better.
Thanks, Anna. So what's our implementation plan? Our plan is to use social enterprise. Everyone knows the idiom, you give a man a fish, you feed him for a day. You give a man a fishing rod, you feed him for a lifetime. The idea behind social enterprise, instead of a fish or a rod, you help them plant sustainable, scalable enterprise, and that way you not only impact one person, but also their wider community. Moreover, you benefit from characteristics of social enterprise. Things like sustainability, so because it produces its own revenue stream, it's not dependent on first world investment. It's scalable, so entrepreneurs from other countries can see the idea and recreate it elsewhere. And also it allows us as the first world investors to pull out. So what's our future vision? Where would we like to be in 10 years' time? We would like to be an entirely self-sustaining enterprise. We want to produce our own revenue. We find entrepreneurs in the communities and teach them how to make prostheses, find the materials, and give it to the amputees. This way, we help the amputees get back into work. The amputees then give a small amount of revenue back to the entrepreneurs, and this gives them a sustainable revenue stream. Finally, each entrepreneur gives a little bit of money back to us in return for product development, ongoing expertise, and connection to the wider community. This way, each entrepreneur is empowering us to scale our idea and reach more and more amputees, helping more people. So where do we start? We need to prove that this is a good concept. That's where you guys come in. We're looking for a $20K investment to run an 18-month project to run a proof of concept. During the short-term plan, we will run 3 trips: a research trip, an implementation trip, and a follow-up trip. During the research trip, we'll find location-specific information on the problem, the solution, and the implementation. We'll bring that back and form a formal dossier. We'll then go back to the country and give this to the entrepreneur, alongside a 2-week training program and everything they need to know about the target audience, the solution, and any business advice they need to start this business. Finally, 6 months later, we'll come back in a follow-up trip. We'll find out if we need to help them in any way, get learnings, and also assess our impact. During our long-term plan, we hope to use your investment to create a proof of concept, to scale up, to get more investment, to scale to a point where we can be entirely self-sustaining. This competition is the first point in that road. We use your 20K to produce a proof of concept. We use the proof of concept to gain funding from NGOs, governmental grants, and crowdfunding. We use this money to scale to a point where we can access other markets like wheelchairs or prosthetic arms, any kind of assistive device, and finally become entirely self-sustaining. Using this business model, we plan to contribute to the Sustainable Development Goals of good health, economic growth, reduced inequalities, and responsible consumption and production.
Cheers, Russell. The input that this project has got so far, we spoke with business advisory companies as well as healthcare companies. We pitched our ideas, and we received feedback that you've seen today incorporated in our project and in our presentation. Our unique selling point is a cheap and simple design. Our deliverable is startup dossiers with designs, continuous support, and connection to a community. The impact that we want to achieve is creation of jobs and increased quality of life. We believe from our calculations that if you give us today $20,000, in the next 18 months, we can provide prosthetics arms for 80 amputees and help one entrepreneur to create his own business. But in the long run, we can have a huge impact on amputees throughout the world. In summary, we intend to help amputees who lack access to affordable prosthetics, utilizing simple, cost-effective design through the medium of social enterprise. Thank you for listening, and we invite any questions.
So what analysis have you conducted in terms of the areas that you intend to deploy this first, in terms of the skill sets, the type of work those individuals will be doing when they're back in the workplace, and how is that contributed to your design for the prosthetics?
So in Sierra Leone, the majority of the work is agriculture, followed by mining and then a little bit of the service injury. So the kind of work we've designed the prosthetic, bearing in mind that we'd like them to get into, we'll be using large basic tools, which this kind of mechanical prosthetic is well suited to.
Explain to us in a little bit more detail how the device works. It wasn't obvious from the photograph.
Yes, if we can get the video to work.
They may have to play the video from the back.
Sorry? If he's gone, it doesn't matter. So basically, if you look at this idea, so the prosthetic arm at the moment is using bite parts, but later on we plan to develop into other things. But it straps onto the arm, and it uses extensions of the back muscles to create tensions in the cables, which causes the pincers to close. It's the same as a normal mechanical prosthesis, with the unique selling point is that it's cheap and low cost. Would you like me to?
I'm just trying to understand what it is exactly that you sell in this case or produce, since it doesn't seem, I mean, you're not selling kits or anything like that. That's all made by local labor. I mean, what is the model for actually, producing product or collecting revenue?
So our business model, our deliverable is only information. So we found that from research, amputees in these countries can't pay for our wage. They can only pay for the wage of an entrepreneur in the community. So our deliverable to the entrepreneur is only information, everything on problem, solution, and implementation, location specific. That's why we have the research trip. And then the entrepreneur does everything else.
If I can add something, the deliverable is the actual design of the prosthetic, and in case we were to expand to other assisted designs, it will be the designs for these cheap, low-cost prosthetics as well.
So I understand that you're asking for $20,000 for this initial trip, right, to get more information. What exactly are you guys going to be doing on that initial trip? How are you targeting these entrepreneurs? How are you finding the talent that you need in order to grow your business?
So just to qualify, what are we going to be doing on the research trip? So we're gonna the main thing we want to do is find location-specific information. So we've done our research from a high-end research papers and that kind of thing, but we can't get location-specific cultural influences. How do they see this issue as, etc., etc. So the main thing we're going into there to do is make relationships and talk to end users.
Business model. I understand if you like, you're selling the intellectual property of the design. Can you explain a bit more about once you've got that picture in place and lots of entrepreneurs working on the ground, what the revenue feedback to you is and how that works exactly?
Okay. Yes. So from our research, we found that we want to make a prosthesis that is something that a amputee can pay back in a year's time using microfinance, so $2.50 a month, which we found is a reasonable amount for them to pay back, seeing as now they have a job. That means that if, from the density of amputees in Sierra Leone, we found an entrepreneur can have access to 160 amputees. If they penetrate that by 50%, that means that they have 80 amputees. That means that each entrepreneur is getting $200 a month, which is 4 times the normal annual income. So far, we've just had the idea, and we've produced this presentation, and we've researched what to do.
Have you, you talked initially about a lot of the amputees were ostracized by the community. And have you thought through the psychological impact of, even though your device is simple and cheap, but as you were to look at it, having a piece of a bicycle on your arm, how that socially would be accepted in the countries you've looked at?
So we know that it's a bicycle parts, but that's our first iteration. So we're gonna improve the design, making it lighter, but also like more pleasant to look at, so that it doesn't look like someone's wearing junk. At the same time, there's a trade-off. And we really believe that the most important, the lesser of the two evils will be wearing something that might not be aesthetically pleasant, but will enable this person to get a job and provide for their family.
That's all the time we have. Thank you.
Thank you.
The graphics are a bit distorted. Okay, no.
This is the
Yeah.
Please note this box. It will turn green when you get started. It will turn yellow when you have 1 minute to go, and red when you're done. It will go through 2 cycles. One is the 7-minute presentation, and then for the Q&A. With your first speaker, would you give
Is that within the time? Within your 7 minutes. Okay. Yep.
Wait.
Good morning. Can you hear me? Is that good? Good morning, everyone. We're from the University of Bristol. My name's Patrick. This is Lottie, Oscar, Matthew, and Robbie. And we're here today to talk to you about Way Around, which is our exciting new app to help everyone get around the city. This is Joe, and he lives in Notting Hill in London. And he wants to go see his friend Julia on the Seven Sisters Road. To do this, he might use a service such as Google Maps to give himself a quick and easy route using public transport. But Joe is in a wheelchair, and therefore this service misses key information that Joe needs to get around the city, such as if there's step-free access on the tube, if there's a steep hill when he gets off the bus, whether it happens to be quite busy that day, or whether the venue itself is even accessible. To find this information, Joe would need to trawl through the step-free tube guide of London. He'd need to find some sort of map to understand if it was hilly at the venue. He'd need to have a reasonable guess as to whether it was going to be busy that day. And he'd need to check the website of the venue to see if it was even accessible. This process is so cumbersome and time-consuming that often Joe doesn't even bother and leaves him isolated from his friends and family.
So what Way Around does is brings together this information into a coherent mapping route planning application for Joe to use. All Joe has to do is tell us a little bit about his disability, and then we'll inform him about the kind of routes we'll be planning for him. So in Joe's case, ones which avoid steps and avoid steep inclines. And we'll also notify him along the route about things like whether public transport might be busy, whether the pavements might be busy, and whether his destination itself is accessible. Joe can change these settings at any time and is completely customizable. And along his routes, he can provide feedback into the system to allow the system to learn more about the details of his needs and refine routes both for him and for other users like him.
There are 1 million people in London alone who struggle with getting around London, and this number is only going to grow as our population ages. This can be split into 3 categories: physical, psychological, and visual. So within physical impairments, this might include people with physical disabilities, elderly, those who are injured, those who might be carrying a lot of luggage, or even people who are pregnant. There's also psychological impairments, such as people with agoraphobia or claustrophobia who would want to avoid busy spaces. And there's also visual impairments for people with low vision or with conditions such as cataracts. We'd start our development process with a physical group, since this is by far the largest market and the data is most easily accessible, and then move on to psychological and visual at a later date. At the moment, London and other cities like it are failing to meet the needs of their citizens. And this is shown by the fact that just 24% of tube stations in London have step-free access.
So what information do we need to plan Joe's route? Well, first of all, there's the locations of the stairs and the step-free access locations in London. And we get that from local councils and local transit authorities. There's also hill gradients, which we can calculate from elevation data from UK government LiDAR maps. There's a level of crowding in spaces, which we can source from telecoms companies. And also we'd like to partner with companies such as TripAdvisor for venue accessibility information to provide a door-to-door service. Once we have these data sources, we can combine them together using custom-built tools and methodologies to process the wide variety of data sources and formats. Using the tools, we can also mitigate any risks of data quality issues. This is then combined into a single network database, which can be used for the route planning. So we combine this database with Joe's specific needs and put them through a custom-built route planning algorithm. This then ensures a smooth journey for Joe from A to B.
The business structure of Way Around is a community interest company, and that's a hybrid between a limited company and a charity. That gives us a legal commitment to purpose, by way of an asset lock, which ensures that in the event of a shutdown, our assets would default to a charity of our a named charity. This gives ethical investors peace of mind. We'd still be eligible to receive charitable grant funding, but would also be able to raise business capital in a more traditional sense, and which is essential to attract investors. We'd be able to take home some profits and pay dividends to shareholders, but a proportion of those dividends would have to be put back into the business to ensure sustainable and reliable growth going forward. We realize that the money in an app like Way Around is in the long run. So growth is key to our success. That's why we're offering the app as a free download to maximize our user base. We'd work with charities to make use of their expert guidance in the field, as well as helping to contact our target market and market the app. We'd also look to partner with corporate bodies, such as Network Rail, who have already shown an interest in the app, to align with their corporate social responsibility and help develop the app. In the longer term, the data from Way Around can be used as a planning enhancement tool to ensure that the development of cities in the future is friendly to those with mobility needs. We can also sell the movement trends of our users to those looking to market mobility products. As well as this, it provides an excellent third-party platform for services such as Uber that might be recommended through the service to take a leg of the journey in a taxi with space for a wheelchair.
To launch Way Around in London, we've identified a number of key cost drivers. Our initial startup costs revolve around the cost of a salary for a small team of software engineers and a data processor, as well as the required hardware and software to get us going. Our operating costs are dominated by the rental of data space, cloud space, for data storage and data processing. Combining these costs over a period to launch of 24 months requires an initial investment of $500,000 US. Now, whilst this seems like a lot for one city such as London, the methodology we have developed here can be easily adapted to work for any city in the world. To release in a new city, we can simply do it in a shorter time and for a lower cost, enabling Joes all around the world to negotiate their way around previously challenging cities.
So what does this mean for our Joe? Well, by removing his anxiety, oh, is that
time? Thank you. Questions? Who would?
You didn't talk about competition. I'm interested, I don't know a lot about the space, but is something like CityMapper beginning to address this? And if they are, would you not be better off partnering with them to try and extend what they do, given that they're in multiple cities with a very sophisticated algorithm?
So I think that is something we'd be interested in. Our key element, we haven't seen any development of from Google Maps or CityMapper in this kind of area. The key thing that would differentiate us would be the data processing system and the algorithm. So after developing that, that would be an exit strategy we would consider to partner with Google or CityMapper.
How's the algorithm different though? Surely it's just taking a different set of data rather than doing anything different in the algorithm itself?
So it's the step before the algorithm of actually collecting the data. This could be on drawing plans of roads, it would be in large databases from councils. I think that's the key difference between what CityMapper is trying to do.
There are also existing services such as Ewan's Guide or Can We Go, which rate venues accessibility, often through a traffic light system, but the data is often very granular. So, for example, in Bristol, there's only about 5 or 6 venues actually rated on the service already. So, and it also involves going to a specific service, which requires more time, it's more cumbersome. So ours is a more comprehensive, provides it all in one place.
Is the system dynamic? And what I mean by that is Google Maps, for example, it's tracking a large number of GPS units so it knows if a traffic jam is developed. Would this know, for example, if a lift at a tube station is closed, it just shut down for maintenance? Does it know that?
Yeah, so I suppose there'd be 2 ways that it would learn things like that. Firstly would be through partnering with those kind of transport providers. They could provide updates to us into that would be automatically incorporated into that database to provide that information, or where that data kind of wasn't known directly by them. that's where that feedback from someone like Joe would come into play, where if he got to a bar on his route that was blocked or something, he could input into the thing like, my route's blocked, and then it would note that and like kind of feed that information back into other people's routes. Can you talk a little bit about, so I'm interested in how you guys are going to maintain this. My understanding is that you're pulling from a variety of different platforms, so like Google Maps, to then overlay them so that you get the information that you need. I'm struggling with where the data storage dilemma is coming from. If you're pulling from others, then what type of data are you guys keeping in the maintenance associated with that data?
Yeah, so it's once we've collated the raw data, that goes into a database network. So Google will have their own network, but ours is different in the fact that it has the accessibility information. So we need to store that information and then use that with the algorithm, and that's where the cloud storage comes into part.
What do you foresee as the biggest issue going forward as you scale to cities outside London, to different countries? What is the biggest hurdle you believe you'll have to overcome?
So I think what we would say would be in that initial collection of the data, where we'd be developing those data processing methods, it would be making those as resilient as possible to account for, obviously, data in other cities is going to be in like a huge variety of formats. Even within a country, different kind of councils and city authorities will provide it in different formats. So I think the biggest challenge is ensuring that those data processing methods are as resilient as possible to account for that. Because once that data is processed and put into one place, that's really kind of the biggest chunk of the work done, essentially.
Where is your main revenue, and who will pay for this project?
So we have a variety of different revenue streams, from potential social care budgets being spent on downloads of the app. But as I explained before, that in the money lies in the long run. So selling the data to urban planners is a very lucrative possibility, as well as selling the movement data of the users of the app to people marketing the products. There's actually a Social Care Act passed in the UK to allow, instead of providing specific services, allowing users to delegate their own care budget, so decide what to spend that on. So there's a possibility to tap into that and provide a revenue stream through social care.
Being able to get revenue streams from a wide variety of places is also really good because it mitigates our risk, so it keeps our company nice and robust.
I'll ask a quick one. So when you did your customer discovery interviews, what was the biggest surprise that you learned as you were looking into this opportunity?
So we spoke to a number of potential users, and one of the main things we discovered was that physical disabilities would be the place to start. Due to the needs of what's required is more straightforward than potentially the other impairment groups. So physical data such as pavement widths, whether the street is cobbled, where the access points for a train are, is probably more straightforward to get hold of. And then also interaction with the app, say for a visually impaired person, adds another layer of complication. So we would, start with like walk before we can run, basically. So start with physical mobility impairments and then move on to the more complex, more demanding ones further down the line.
I think the other thing that was the biggest surprise was the amount of people that turned around to us and said, "Why doesn't this exist already?" They said that we're in 2017. Why, if I'm in a wheelchair, can I not just be given a route? And I think that was the thing that surprised me the most, is how pretty much everyone who we spoke to said that to us.
There is a change in our schedule that the University of Southern California will be next, not the University of Denver. They're flipping slots for technical reasons. It has nothing to do with any preference of any kind.
Good morning, everyone. I'm so happy to be here presenting to you on behalf of my team, Interim. And yes, a mobile app that prevents and eliminates pre-hospital delays that prevent stroke patients from getting the treatment that they need when they need it. I'm Manjima Sarkar.
I'm Adam Walker. I'm David Sealand.
And we are Interim. So picture this. You're driving down a freeway and suddenly you start swerving in and out of lanes. You've always been a good driver, so you're not quite sure why this is happening. Your vision begins to blur and your head begins to spin and you're becoming concerned. As you pull into your driveway, your partner tells you to call 911 and go to the hospital. You tell them not to worry, you'll sleep it off, it's probably a lack of sleep, and you go and take a nap. Unfortunately, when you wake up a couple of hours later, you're not feeling better at all. In fact, if anything, you feel worse. That's because in the last couple of hours, you've had a stroke. Sounds terrifying, but that's exactly what happened to my uncle in March of 2015. Stroke is a personal problem for all of us. 1 in 5 Americans will have a stroke during the course of their lifetime, which means that all of us know someone who has had a stroke or will have a stroke. With statistics like this, it's quite evident that preventive measures are of the utmost importance. We'd all like to think that if we were faced with a medical emergency, we would call 911 and seek treatment immediately. Unfortunately, statistics show that that simply isn't the case. Only 14% of stroke patients call 911 in response to stroke symptoms, and only 25% of them actually ever make it to a hospital. During the first few hours after a stroke, you can be given intravenous TPA, and it is the only FDA-approved stroke treatment. After that time window passes, you can no longer be given that drug, and more expensive and costly interventions are required. Statistics show that only 3% of total stroke patients in the United States receive TPA, and this is the only intervention which is successful at alleviating symptoms. So, what exactly is our solution? Our solution is to create an app that eliminates these pre-hospital delays so that patients can get to hospitals quicker. My uncle ended up going to the hospital 18 hours after the onset of his stroke, underwent an angioplasty, spent 2 weeks in the hospital, and has suffered from permanent speech and memory problems since. If we can get patients to hospitals quicker, then we can ensure that their interventions are cheaper, less invasive, and more effective. During the course of our customer discovery process, one of the main questions that we were asking was, why do patients not call 911? We found out that most patients don't think that their symptoms are serious enough to warrant a 911 call, and many of them find that the process is stressful and expensive. As in the words of one of our interviewees, if I haven't had a stroke already, the blaring lights, rush of people, and resulting bill will induce one. So that means that patients who do not call 911 need an alternative so that they can seek professional advice and help, so that they get to a hospital quicker and get the treatment that they need when they need it.
We are creating a 24-hour on-call network, a telestroke network of neurologists that are available from a seed hospital in LA County. Once a patient enters the at-risk population, their doctor will walk them through downloading this app and teach them how to use it. A patient can scan in their insurance card, and our app will create a database of medical facilities that are covered under their insurance network. Once a patient experiences symptoms, ranging from the classic stroke symptoms of facial drooping, arm weakness, or speech slurring, to more commonplace symptoms like dizziness or nausea, they can call in to a neurologist and seek a professional opinion. Using either video or phone call technology, the patient can speak with a neurologist, and decide what the best option for them is, staying at home or going to a hospital. The majority of the time, the neurologist will advise them to go to a hospital. Many studies we've looked at have said that patients are much more likely to go to a hospital if told by a professional. Our app allows patients to receive access to a professional opinion from the comfort of their own home. A neurologist can then, once they give a patient their diagnosis, they can send that diagnosis and any kind of prescriptions to the medical facility that the patient is heading to. This allows the facility to prepare treatment and imaging equipment for when the patient arrives. Our app, by allowing patients access to a professional opinion from the comfort of their own home, seeks to allow patients that
are experiencing stroke to get to a hospital faster and receive TPA within the proper time window. This is how we picture Interim, our app, fitting into the current revenue structure of stroke care. Doctors will be recommending this app to patients, constituting our user base. Right now, patients pay insurance that pay hospitals, and our revenue structure will be fitting into the insurance part. Insurance companies save a significant amount of money when patients receive better care. TPA is much cheaper than more invasive procedures. By taking a cut of the money that insurance companies save, that's where our revenue structure will come in. Our primary expenditures are in setting up the initial telestroke network and in paying apps and app developers to keep our app up to date and bug-free.
The numbers show that our business model is quite lucrative. The average cost of stroke intervention in the United States currently is nearly $28,000. In contrast, the cost of intravenous TPA delivery is only $2,000. Insurance companies, since stroke is the third leading cause of death in the United States, all insurance companies cover a large number of patients who will suffer a stroke yearly. So they stand to save a lot of money from services like ours. So what are some of our next steps? Our next steps involve furthering conversations with insurance companies Blue Cross and Aetna to ensure that we can enter into annual contracts where we provide them with our service and they pay us. We also need to finalize talks with UCLA Reagan and USC medical centers who already have existing telestroke programs, but we need to expand them to a larger population. Thank you.
Can you talk a little bit how this is different from some of the competitors out there? I know that this concept of calling in to a doctor is kind of new and it's been on the rise. Can you explain how your app is going to be different than the competitors in this market?
So currently, there are places where you can call into doctors, but those are usually general care doctors. So you call in for things like headaches, you call in if you're like nauseous. It's very general. This is intended to be an emergency service. So when you're experiencing stroke symptoms, it's something to get you to the hospital quicker. And the main point in here is not the diagnosis that the doctor is giving you, it's the point that they're telling you to go to a hospital so that you get to a hospital immediately after onset of your symptoms.
And in our market research, that professional opinion of a doctor just telling them to go to the hospital is a lot just kind of the push that these customers need.
Expectations in terms of how many will actually use this? I know you said at the beginning only 14% of stroke patients actually call 911. So what are we expecting in terms of how many of the at-risk population will use this? And follow-on question there, how did you determine the at-risk population?
So the at-risk population is determined by common medical factors like age, diabetes, or history of stroke in your family, things like that. In addition, we were planning to aim for like maybe 2% of the population who is at risk in Los Angeles for in the first rollout of our app. So we're aiming low. Because this is something that doctors are recommending to patients. So we think that it will take time to catch on, but in the first rollout, maybe we can get to at least 2% of those patients.
And in our customer discovery interviews, patients are hesitant to call 911 because of the stress and the kind of the financial aspect of it. But our app allows them to call from their home and just talk to a doctor like they're talking to a family friend. And that's where our biggest advantage is. It's the comfort and access to a doctor from their own home.
The success of the app obviously relies on having enough doctors qualified, on call and available. How do you actually build that doctor network to make sure that you actually have availability?
So as we mentioned before, USC and UCLA currently already have telestroke networks, but those networks are used for, within their network. So for example, USC facilities allow doctors at one hospital to contact doctors at another facility. And we talked to one of the neurosurgeons who was critical in setting up that network. So all we have to do is take that network where doctors are already available and expand it to a larger population of people who are not already in the hospital. Yes, so the major challenge is actually, as we mentioned before, expanding it to other people, because right now, doctors already have the facilities at their clinics, which allow doctors at one place to contact doctors at another place. This is on the patients to have the technology where they can access doctors who are probably not near them at all. So that is one of our major difficulties, and another difficulty is in the cost. The initial cost of setting up that network will be one of our major problems.
And however, we hope to solve those problems by aiming this app at not only those possibly affected by stroke, but also their relatives and loved ones who may be more comfortable with smartphone technology. And additionally, in terms of rolling it out to people and having people use it, stroke is one of the most common medical emergencies experienced by not only the American population, but the human population. So we're really accessing a large market here.
Couple of questions about market. One is, let's say you're part of the system in greater LA, but you're now visiting in Washington, D.C., and you have an issue. How do you handle it when you're out of town? And second question is, what about for other things, like, say, an equivalent app for heart attacks?
Designed to be remote, and as we mentioned before in our workflow, when a patient registers in our app, they scan in their insurance card, and we create a database for them of facilities where they're covered under their insurance company. So they do not need to be in the greater LA area to access or talk to a doctor who is in the LA area. It's designed to be remote, and then we can send them to a facility where they are covered. As for other conditions, currently we're limiting it to stroke because that already is such a large population and a large market that we need to target, but we do anticipate that it would be useful for other conditions in the future.
Are you concerned about liability as it relates to when you have the issue of false positives? Basically, if you call in, the doctor more than likely is going to say, my chest hurts, come in. And so therefore, I mean, do you need a urologist to do that? Because in essence, no matter what happens, they're probably going to say, come in. So I'm not sure the value proposition based upon what you're doing.
The idea is that patients will be able to access the neurologist from home and would be more comfortable calling that neurologist and they would trust a neurologist and that kind of professional opinion. And even though they're not calling 911, being able to access that at home would help them do that. And then as far as liability goes, if at this age and this risk population, even something as small or as commonplace as dizziness and nausea could be conducive or could be indicative of a stroke. So by a doctor encouraging a patient to go to the hospital, it's better safe than sorry. So that would kind of cover the liability aspect.
Yeah.
We're out of time. Thank you, guys. So that concludes our morning session. We will have a lunch served, I believe, where we had breakfast this morning, and there will be a panel discussion on today's engineering challenges and tomorrow's industries. That will begin at 11:45. We will pick up again at 1 with the remaining teams in the competition. And we will also have a chance during lunch to see the prototypes that some of our teams brought and to have them demonstrate what they've built. So please make yourselves comfortable until lunch. Thanks.